Hello everyone. In this video I will teach you how to upload your own network data into Gephi and how to export those data to use in another program or in your paper after you've done some analyses in Gephi. So if you want to upload your own data, you need two types of files. You need a nodes file, which describes the characteristics of the actors in the network or your nodes, and an edges file, which describes characteristics of the relationships between those nodes. So if we open the nodes file first in Excel, you can see it's an Excel file. It looks like this. You see two columns, ID and label, and these columns must always be there if you want to upload a nodes file in Gephi. It might not look so neatly in your case. You might rather see something like this. If you go back and you open the nodes file with another program, with Notepad, then you see this. This is the raw data. So this is the formatting of the data, and you can select all of this, Control A, Control Copy, close this, and then open Excel from here. Just a new Excel file, and now I paste it in the first column. And it might be that when you opened the CSV file in the first place, it looked more like this. So the raw data CSV format. But Excel can still open this, and many programs can open a CSV file, which is why usually you want to upload it in this type of format, because you can use it in other programs afterwards or before as well. So, but we can transform this to the Excel format again. If we select the first column, we go to Data, Text the columns, and then we need to identify a separator, which in this case is a comma, because you can see that every column is separated by a comma. So we need to tell Excel that. It thinks it's a tab. It's not. It's a comma, and now you see that Excel recognizes the data structure correctly. So we take Next. We leave this as is, and we click Finish. And you can see now you have your Excel type format again for the data structure. So this is your nodes file. Any nodes file must at least have an ID column and a label column. The ID just gives unique identifiers to the nodes in your network, and the label variable characterizes those nodes. You've used this label variable to display next to a node last Tuesday as well, so that's the same thing. In this case, it refers to the names of individuals who have cited the 1967 Milgram paper, Stanley Milgram's paper on small world networks, or the small world experiments, a very famous study, network study, where he selected a number of Americans randomly, and those Americans were instructed to send a physical letter, so an actual written letter, to a random American somewhere else in the country, by regular mail, of course, because there wasn't any internet in those days. And of course, you wouldn't know this other random American, and so you were requested to send this letter to a person that you thought might know this final person that the letter had to be sent to. Because you did have some information about this final person, for example, about his or her occupation. So you send the letter to that person, and that second person gets the same instruction. Please send this letter to the final person. And so the process would go on and on. And what Milgram and his colleagues found was that it only takes 6 steps for an average letter to go from the first to the last person. And so later this has famously become known as the 6 degrees of separation, meaning that the whole world is really a small world because social networks are structured in a certain way. So it's a famous paper and has been cited by a lot of other academics. And that's what you see here. All these people have cited the Milgram paper. So we could, if we wanted to, add information about these people in this data file. So maybe we know something about their age, and we could add that to this file. If we knew the age of these people, and we could add as much information as we want, and it would look like your standard SPSS or Stata file or R file that you normally do the statistical analyses with. But the bare minimum that you need to upload it in Gephi is an ID and a label column. So we exit this file, we don't save it, and now we go to the edges file, which is also a CSV file, has a similar structure, but now you can see we have a source and a target column. And again, these are necessary to be able to upload an edge file into Gephi. This is called an edge list. So every row here from source to target represents an edge or relationship. So in this case, person 3 has a tie with sends a tie to person 6. And these numbers correspond to the ID variable in the notes file, so that you know who is who. You could also upload network data in different forms. So you could have a social matrix where it would be something like this. Yeah, person 1, 2, 3, 4, and here also person 1, 2, 3, 4, like in the Medici example, where maybe person 1 has a relationship with person 2, the other way around, and you fill a network in like that and save it like that. You can also upload a social matrix like that, but usually, again, because it's simpler and more straightforward, people use an edge list where every row is a tie and goes on for all the ties of every person. So you always need to have a source and a target in an edge file. Again, you can add information here in the other columns if you have that information and if you think that is interesting for your research question. So typically you will see something like weight here, if you know something about the strength of that relationship, or maybe you know something about the duration of the relationship. How long has a tie already existed? 4 years, 6 years, 7 years, and so on. So this might be interesting information, but this is not necessary information to be able to visualize a minimal network in Gephi. So that's the edge file. We exit the file, and now we go to Gephi. If you open Gephi, then you want to have a new project because we don't have any data available yet. We need to create the network, so we have a new project, and then we go to the data lab, and in the data lab we go to import spreadsheet. So this is where we access our CSV files. You go to the folder where you saved your files, and then you can start with either one. So you can start with the edges or you can start with the nodes. Let's start with the edges in our case, and then you get to this screen, the general CSV options, and you need to check whether Gephi has guessed these categories correctly. So first of all, does it have the right separator? You can see the preview here, and you can see that it has been done correctly. We have a source and a target, looks exactly the same as in our file, and we have indeed a comma separator. But you might see something like this, where you have semicolon as the separator, which is not correct, and then Gephi will give you an error message and say something is wrong. And you will see the raw data here. So we go back to the comma separator. So this is correct. And indeed, it's also an edge table. That's the type of data that we import here, not a nodes table or not a complete matrix, not a complete network. And it's a UTF-8 type file, which is the simplest file you can get. So this is all good. And then we go to the last window, where first of all you may want to you can actually say something about the time representation, but that's only relevant if you have multiple networks for multiple points in time. As networks evolve over time, we call those dynamic networks. But here we have just one network for one point in time, so that's irrelevant. And the columns we import are the source and the target. And as you can see, we can't change those. They need to be there. So we click Finish. We get our final report before we get the data. A couple of things are relevant here. First of all, the graph type is specified as directed. It can also be undirected or mixed. In this case, it is in fact directed because it's a co-citation network, so you can cite somebody else in an academic paper, but that other person does not need to cite you necessarily. So there can be a directed tie from one person to another, and it might come back, but still it's a directed tie. So that's one. It gives you the number of nodes that you can check whether that makes sense, and the number of edges as well from your edge table. That's the number of rows in your Excel file. And then we have a new workspace because this is new data. We haven't uploaded anything yet. And it gives also here an issue. It says parallel edges detected, and parallel edges are the same edges between the same two nodes. So Gephi has registered some instances where there's a tie from or a citation from one person to another, and that has occurred again and maybe yet again. And so that's what it detects here. But that makes sense here because you can cite another person in multiple papers. So you can have parallel edges. So that's fine. We click OK. And now you can see that we are in the data table nodes, in the nodes tab where we have the nodes. But we have no information about the nodes, which makes sense because we haven't uploaded the nodes data yet. We go to the Edges tab. You can actually see the data that you uploaded. So this is the source and target data, and then Gephi has asked us whether this is directed, which it is. It gives the edges a separate ID, so every single edge gets an ID, and maybe more importantly here, it also has a weight. And so this has to do with the parallel edges before. This is basically a count of the number of papers, the number of times a person cites the same other person. So person 6 has cited person 6, person 3 has cited person 6 30 times in this case. So we have a weight to the edge. So if we go to overview, we can already see our network here, and if we have a stronger tie with a larger weight, for example, here, the thicker edges are those edges where the weight is higher. So that's all fine, but now we need to upload our nodes table as well and the characteristics of the nodes. So if we go again to import spreadsheet, we open the nodes file in the same under the same tab, and we open this file and we get to the CSV options again, and again it has guessed correctly that we have a comma separated file. It is indeed a nodes table, and you can see that the ID and label columns are correctly uploaded. So here we have the names of the authors. We click Next, and then we want to import these columns, ID and label. Again, we don't need to do anything with the time representation, and we click Finish. It finds no issues. For nodes tables, it usually says that the graph type is mixed. You can leave that as is. It's not really important because it's a nodes table anyway. So just the nodes, no edges. The number of nodes that are in the nodes table, 396, and the number of edges, which should be 0 for a nodes table. Now, in this case, we don't have a new workspace. We already have the edge data, so we need to append this nodes table to the edge data that we already uploaded. So we click Append to Existing Workspace, and we click OK. So now, again, we get to the Notes tab, we see the IDs, and now we also see the labels of these different persons. So, and if we go to the edge table, we still have all our edges in this edge table. So now we have our complete network of all the nodes who have cited at least once the Milgram paper, as well as all the co-citations between those different authors. So if we go to Overview, then we have our hideous looking network. And now you can basically do all the stuff that, visualization wise, that we have been doing last Tuesday. So you can, for example, look at this in a Yifan Hu algorithm layout algorithm, and you click Run, and you can see the network blows up. So we right click, we can move the network. You can also center the network if it has blown up too much, like this. You can center the network here, and then you get a nice centered graph again. Now, as you can see, there are quite a few isolates, and these are people who have cited the Milgram paper, but that's about it. So there are no others who have co-citations with these authors. So we have 396 nodes, but not all of them really have edges. So like you did for my brother's Facebook network, you might want to filter those isolates out. But we'll leave that for now. We'll leave that as is. You can play around with that yourself and maybe visualize the graph differently. But for now, I want to show that in the other than the filters tab, in the statistics tab, we can compute lots of structural characteristics about this network, or of this network. So we've looked at 3 types of degree centrality so far. So we could compute one of them. So here under average degree, if we click Run, the program will actually compute the degree centrality for this network, meaning the number of ties weighted by the number of times you see citations between any the same two persons. So that's all added up. But here you see that degree distribution. A small remark here: this is a structure for a degree distribution that you will often see in larger networks, where you have quite a few people with no or just a few ties, and very few. So there's lots of people with few ties, and as the number of ties goes up, you can see that there are fewer people who are citing and get cited much more often. And you see there's one outlier here, which if you look that up, if you go to Data Lab and you go to your notes table, you can now see that whatever you have computed here in Overview under Statistics, whatever you compute, if it's a node characteristic, then in your Data Lab afterwards, under the nodes table, you will actually see those computations for all the actors in the network. So we've computed degree, and we can sort that like we could in Excel, and then we see quite a few people with 0 degree, with no citations other than the one citation to Stanley Milgram's paper. And you can see who is most central, and that is, not surprisingly, Stanley Milgram himself, who has cited his own paper and has since been cited a lot by all these others. And because this is a network study community, those have also cited each other quite a bit, but he is the most central actor in the network. So you can compute those statistics here. You've also maybe already have looked at modularity, and under network diameter, you can calculate the other 2 types of centrality that we have looked at in the lecture of week 4, betweenness centrality and closeness centrality. Here you have yet another type of centrality that you can forget for now, but that you could also compute for a directed network. but we won't do that for now. We just stick with the degree. You can see on average there are 4 citations between any 2 individuals in a network. And so, okay, you've got an idea about, the important stuff, the important structural messages in this network, and then finally you want to export these data in order to use it maybe in a table in your paper or in SPSS or in any other program. And for that, you need to export it to CSV format again. What you could, of course, do anyway, and you're advised to always do, is to save this file as a Gephi file so that after today you can open the network again as a Gephi network, and you don't have to upload the same network again via the CSV files. So you can go to File and then Save As, and you can go to your folder. So, and you might call this, let's say, citation network, and then here you can actually save it as a Gephi file. So now you have citation.gephi, you save that, and after this you can just open Gephi and open that file via File, Open, Citation. We won't do that now because we already have it open, but sometimes you want to use it in other programs, and not only as a Gephi file, and other programs can't read Gephi files, so you want to export it as raw data again. So if you're in your data table with this extra data that you now have, you can export this table, and let's say we call it results, and we want to save it as a CSV file, which can be read by many programs, and we save that file. You could do the same for edges. If you have computed any edge characteristics of some sort and you're interested in that, you could also export this edge table again. So if we go to our folder where we now have these results, again in CSV format, we can open these results. And you can see that the same data that we computed in Gephi, and in addition some weird time set variable that we don't need because we don't have longitudinal data. But here we have the same IDs and labels, and we have the in degrees and out degrees and the degree, which is the sum of those things. And this we could use well, either in a description, in a descriptive table, in a paper, or maybe in SPSS where we do a correlation analysis. So does, for example, in degree correlate with out degree, or any other type of statistical analysis that you want to do with these data based on network structural aspects. So this is how you export your Gephi data, and that basically wraps up what I wanted to say about importing and exporting data in Gephi. So thank you very much.